Let's do an example problem involving unit tangent, normal, and binormal vectors for a vector-valued function. Let's try to prove that the derivative of the unit binormal vector b is parallel in the same or the opposite direction as the unit normal vector n. Okay, so here's my answer. What do we know about the unit binormal vector b? The unit binormal vector is equal to t cross n. So if I take the derivative of my unit binormal vector b, I could use the product rule for cross products. And I get t prime cross n plus t cross n prime. Now, n is defined to be t prime divided by a constant to make it a unit vector. So in other words, n and t prime are in the same direction. They might have a different length, but n and t prime are in the same direction. When you take the cross product of two vectors that are in the same direction, you get the zero vector. So this is the zero vector, 0, 0, 0, meaning that b prime is simply t cross n prime. Now, when you take the cross product, what you get is a vector that's perpendicular to the two vectors you started with. The purpose of the cross product is to get a third vector that's at a 90-degree angle to the first two vectors. Therefore, b prime is perpendicular to t and perpendicular to n prime. So thus, what I'm going to say is b prime dot t is equal to the number 0. This means that b prime and t are perpendicular. Okay. Now, we also know that b dot b is equal to 1. b is a unit vector. It's a unit vector because we're taking the cross product of two unit vectors that are at 90-degree angles. So you could prove using properties of the cross product, I believe we did that in an earlier video, that the length of the unit binormal vector is 1. And when you do the dot product of a vector with itself, you get the length squared. So again, the reason that this is true is because b is a vector of length 1. And when you do b dot b, you get the magnitude of b squared. So this is the, here, I'll write that down. This is the length of b squared, because b dot b is a length of b squared. So we have this expression. I could differentiate this expression the same way I took the derivative of this expression. So I'm going to take the derivative of this expression, and I will get the product rule over here. So I'll get b prime dot b plus b dot b prime should equal 0. The derivative of 1 is 0, and the derivative of this side is the product rule, the dot product rule. So therefore, I have that 2b prime dot b equals 0. That means if you think about what the dot product is telling you, when the dot product is equal to 0, that means that the two vectors are at 90-degree angles with one another. They're perpendicular. So we have b prime and b are perpendicular. Okay, so here's the situation. B prime and T are perpendicular. B prime and B are perpendicular. If we're in R3, there's only one choice. We're only one choice. B prime has to be something perpendicular to T and B. Well, that's N. That's N. So therefore, we see that B prime is parallel to N. Again, because N is the vector in the direction that is perpendicular to both T and B. Okay, so that was a nice little problem that used a lot of the concepts we've seen most recently in our course. I hope you were able to follow along. Excellent.